Hello everybody, lecture 7 part 2, which is related for today lecture. You may remember we already started talk about a big data ecosystem, which is including several parts, steps. It was data ingestion and ETL process. Then we start first part of ecosystem. It is big data storage system. We start to talk about the big data storage system compared with the traditional one. Then we came to big data tools. We introduced three important big data tools, which is very popular for practical implementation of big data. The oldest and famous one is the Hadoop. And then we came to a MapReduce, which is part of Hadoop, and introduce Hadoop distributed file system, HDFS. We finish MapReduce, and now we are going to touch Apache Spark. So Apache Spark is very popular, very strong, and this popularity because it's very user-friendly, and to understand Spark, we have a like processing, storage, analyzing, right? This is three main pillar of the big data ecosystem. So we would like to see which one Spark is strong. So of course, Spark is not strong for storage. Mainly is a processing and for analyzing. So this is the main strength of the Spark. So this is primarily a processing and analyzing tools, and it is not designed for storage. So, but we can, integrate with some storage system to perform its task. But mainly, storage, it is not good. If you want a distributed storage system, big data, you need to touch for Hadoop and other things. But when you come for processing and analyzing, for big data analyze and processing, we already discussed what is the meaning of the, this for big data analyzing. So far, we discussed about that, and we will talk again more about that. Just for your information, we will come to this slide again. I brought this slide to quickly remind for you what is the difference between processing and analyzing. Storage is clear because we already explained. For big data ecosystem including three parts: storage, processing, and analyzing. What the difference between the processing and analyzing is, in the processing, storage is a storage, right? Storage means you store data distributed and manage the keeping data. But process and analyzing, when we talk about the process and analyzing, in the processing, prepare and organize raw data for future usage. But this is some sort of preparation of data. Then we need to do analyze. Analyzing means the main job of the AI. When AI and big data integrated, the big data analyzing play important roles. Extract the insight and knowledge from proceed data. So this is the main objective. And the another one, for what is the main focus of the processing is the data ingestion. You remember, ingestion means eating food. And bringing ready for doing main task, and which is pattern detection, hypothesis testing, prediction, and visualization. So this is done. Tools is a Spark and also a Spark. Specifically, if we have time, then we will also touch MLlib in the our slide, talk about that one and do some practical in hands-on sections. So the two important part of the processing, which is batch processing and real-time processing. Batch processing means you define some specific time. In a specific time, you do some processing, but this is continuously processing. So This is the two important, part, batch and real time for data preparation. But in the analyzing, you do real time inside and very deep analyzing. So this is what is the output when you do big data. This output is ready for input of the data analyzing. So data will be unstructured data converted to the structured data, and this is clean to use. And then you use for this one. Now you understood when we are talking about the data processing and big data processing and big data analyzing. Okay, let's back to our slide that Spark is good for processing and for analyzing, right? So we already explained what difference between processing and analyzing. So processing is very important for Spark. So if I show you next slide, you will see here that the processing has a 3 tick and then analyzing, but it is not good for storage. So this is the point. This is very nice, section showing that primary use of the Spark, it is good for doing processing like batch and real-time data preparation processing. And then second, support, which is including many deep insight detections, like when we have some wisdom, we want to come to some pattern, then we use the analyze. So storage not desired. So this is relies on the Hadoop like HDFS format or Amazon S3. So let's back to previous slide. So as you can see here that Spark excels showing very good power in data processing task. Why Spark is good, and compared to Hadoop, we will compare later. Spark doing in-memory computation, but Hadoop is based on disk-based computation. So this is much faster, and one of the important point of the Spark is processing through the memory, as well as parallel processing. We will talk later. Simultaneously, we will divide it doing partition our data and process through the parallel processing. Support batch and real-time processing. So it is very flexible to different format like JSON, Parquet, CSV, and even some sources like HDFS, means Hadoop distributed file system, and Amazon and Kafka as well. Another part which is Spark Analyze, which support advanced analytics to do some process which already mentioned, like ML Labs for data visualization is similar. Data visualization, Power BI is very famous, and we can use this capability of Spark for data, especially Spark UI. So in the hands-on practice, we may touch and do some implementation for Spark UI. And Spark SQL, we will talk about the abstraction later. That is Spark capability to do through some data abstraction. What is the data abstraction? We will talk later. So as I explained that no Spark focus for storage. So in that case, Spark use the Hadoop and other available tools like common integration between the Spark integrated with the Hadoop or with the Amazon, or any NoSQL like MongoDB, Spark will integrate it, or even in a Hadoop or is a HDFS, and for other Spark Hive or a Delta Lake, which is a data warehouse, is kind of a storage, had a Spark connected to that one. So Spark string, as I mentioned, is for processing and analyzing. So for transferring data and driving insight. So this is the for Spark advantages. So let's recap some pros and cons of Spark. So when we do some comparison to see the advantages and disadvantages, later on I will explain Spark and Hadoop MapReduce and a little bit technical talking, and then I will talk about the data abstraction in Spark, which is very important. Okay, for pros, as I told you, processing through the memory. So data is stored in the memory for faster data retrieval. You know, if you know about the operating system, in operating system, process mostly in RAM, in the memory. If the RAM full of process, then send the task and send, any jobs to the hard disk. So process in the hard disk. So that's why RAM is much expensive than, storage hard disk. So Hadoop, this is that. So this makes many technical documents said 100 times faster of MapReduce, because MapReduce is based on the disk-based processing. So Spark support many programming language, Java, Scala, Python, and R. So Python basically has been written from Scala, but is very matched with the Python and as well as R and Java. So this is very great, versatile APIs which support, and working with the Spark. So Spark, another strength, has a very strong libraries. Some library, built-in library for SQL, and which makes Spark getting superior than the others these days. I will talk about a little bit ecosystem of big data tools. You see, these days talk about from maybe 10 years ago, only talk about the Spark. So that's why I choose Spark for our classes. And some disadvantages of Spark, when you are always working, processing on the memory, that makes costly for memory management. So you should have a very good memory when you go for big data analyzing through the Spark. But if you use the MapReduce Hadoop, then you don't need have a very strong memory. So for cluster management require very efficient cluster. We will talk about the structure of Spark, which is including several parts: driver, cluster management, and cluster itself, and executor. I will talk about that. And there is a limitation. Actually, for real-time processing, Spark good, but through real-time processing, it is is very very quickly processing. That would be challenging. If you are very small, changing and process happen during the millisecond, then that is challenging. And then you need to go for the others technical tools. So another disadvantage is Spark not optimized for handling very small file. So this is reduce the Spark performance. So let's see from another direction, touch a little bit the core feature of Spark. One is the speed. So as I told you, it's very fast. So this is good because memory, and offer a specific programming intuitive programming level support disk persistence, and in-memory caching. So in that case, Spark is very good, improving especially Spark SQL for doing queries. Deployment flexibility, so it is good. You can use many platform like standalone cluster management, which is built in inside Spark, or some integration, Hadoop integration, like Hadoop Yarn, and or for some Apache methods can be integrated for Spark. Real-time processing, low latency, not true real-time. True means is very, very little change to process, processing within very short time. It has some problem, but basically Spark is good for data real-time processing. Polyglot support means a lot of high-level APIs. I already talk versatile environment. So this is this one, and the 6 is scalability. So a single node that makes to scale from a single node to thousands of nodes, which is Spark can do partitioning. We will talk. So for example, you have a data, you can make it small, and then for each one your data do several processing, and this processing you can put like, let me draw, in different computer, for example, in one country, another city, another, places. So easily distributed data, process everything through this scalability. So wonderful. Let's compare Spark and MapReduce. I will explain this comparison within a few slides, around the 4 slides, to emphasize what is really, difference between Spark and Hadoop MapReduce. First of all, let's look at MapReduce procedure through this graph. And then in the next slide, I will explain about this one and then compare together. So if you look at here, please be careful. This is very nice figure, nicely, do comparison between Spark and MapReduce. So as you can see here, input is the HDFS. So data is stored in the HDFS format, which is fundamental system in Hadoop. Then processing, you remember, including map and reduce. So map, we already explained what does it mean map. Find each word and map together. For example, some word repeated here, then this will be, say, number 3. If another word here, then saying this is like 4. So this is doing the map. So break input data to the smaller keys. So this data will be divided to smaller keys, and then map to the, here doing the map, reduce the aggregation result from the map. So we already discussed about that. Output is a what? HDFS. So this is the structure of MapReduce. Now let's see Spark. For Spark 1, input is multiple input. Is not HDFS. Is can be, but can be another, like streaming data, like Kafka, like Excel file, any other format. So input is not always is a multiple input here. So you can see is not only HDFS. In the Spark is a multiple receiver, but here only input the HDFS in the Hadoop. And the processing using the RDD, we will talk about the RDD, resilient distributed database. So this is one of the data abstraction in the Spark. Spark has a many data abstraction to do process. One of them is the RDD. So processing do based on the RDD, which allow memory computation. This workflow avoid repeated disk input-output by processing directly in the memory, not from the disk. And then processing flow, another important part which is not exist in the MapReduce is partitioning. This make the small pieces. So one piece here, one piece of the, for instance, yellow is here. So this block of data go partition in different places. This can be Seoul, this can be USA, this can be Iran. This data will be maybe located in India. So this is the important point of Spark. And the result from process partition are combined and written in output, which can be here, can be HDFS or any other storage. So more flexibility, this is the point. When you compare with the, Hadoop. So let's two more slides. So core processing is based on the memory, but this is the based on the based on the hard disk. So process faster, but generally compared to Spark is slower, is the disk based. So Spark offer high level API in many languages, but MapReduce primarily in Java. So this is the problem, is not much match with the Python. And in terms of the mechanism for fault tolerance management, since Spark using RDD format, which partition in different cluster, this is the recompute loss of data with it, data redundancy. But in another side, MapReduce uses HDFS to replicate data across the node for fault tolerance. So this is the weakness. So use case, so real-time project, AI project, Spark is very good. But MapReduce is for some not quickly runtime changing, is long-running batch job, and you don't need real-time processing. MapReduce works very well. This is the comparison between Spark and Hadoop. So let's bring three Spark, Hadoop, and MapReduce together in the next slide. So Hadoop is a powerful framework, right? Because using the as a basic distributed storage and long time, and even many formatted, is based on the Hadoop. And key component like because of the HDFS and MapReduce and Yarn, which is based on the Hadoop family. So MapReduce itself is programming model parallel processing. Work in two steps. Map and reduce for reduce data aggregation, and map for data breakdown. For parallel processing, when data disk-based processing, not real-time processing, MapReduce would be good. Spark, in another aspect, why these days popular? Because it's memory-based, faster, is a Spark SQL, a very good match with the deep learning AI. So that is wonderful. Now, let's, from now on, we are going to start very important part, which is data abstraction. Before we go inside that section, can you please pause the video and think about what the data abstraction means. And understanding of data abstraction is very important to understand the data abstraction in the Spark. So this is very important. You understand really what is the data abstraction. Pause it, please, and then continue the video. Okay. Data abstraction in Spark simply distributed data processing by providing logical representation of data. So when we are talking about the data abstraction, we are going to define some logical representation of how data and how data itself and how data movement. So in the data abstraction, two parts: data itself, how organized, and how movement. Why we need to do some rules, logical conceptual thing? Because we are going to do distributed computation. Big data is very important. We want to avoid any error, any problem for scalability. Operation is not in one place, is in several places. So we need to define for this sort of item error management, processing different place, and distributed data. So we need very good regulation. So this is, if emphasize why data abstraction important, I could easily say for why data abstraction it is important at this moment, and the way I'm explaining is wonderful. Why? Because many concepts in Spark is very confusing, but I make a very logical step to come to those concepts, and then that makes your mind easily follow the concept of the Spark. So one of the reasons we need data abstraction when we start to go for Spark specifically, and this abstraction is very important before we touch Spark, hands-on practice. So first of all, simplification of complexity, because we will have many separated process through them, through the, let me change the color, through the distributed part. And we need to simplify from the APIs across the cluster. What does it cluster means? When you have some portion of data in different places, you want to big data analyzing, each one is a cluster. Another advantage is, which is somehow is similar together, scalability and fault tolerance, which here I mentioned. This is automatic recovery from the failure. So because many section your data and you're analyzing divided, to the file in a main file. So also flexibility is not only focused on HDFS, but also is based on the different data type structure and data, even different type of the processing, like batch processing means a step-by-step predefined processing or real-time processing. And another point that makes data abstraction important, that makes optimized performance, is a catalyst optimizer for our query execution. Also, we will talk about the DAG later, which is important. Using is like you show every step by graph, but is a one directional graph, is not a cycle based, because is a acyclic. We will explain later. So this sort of point that makes through the data abstraction. Okay, now we are going to see this data abstraction Spark real example. There is a 5 important Spark data abstraction. So let's see in the next slide. So that is RDD, data frames, data sets, DAG, and Spark SQL. You know, this is based on the order. When the Spark introduced, use RDD first and then second data frame, and then this plus data frame combined together come to the data set. So data set is combination of the RDD and data frame. So this is three main. So these three is the main abstraction of the Spark. And later on, there is a supportive abstraction, especially DAG, which is a very helpful backbone of the any Spark computation. And Spark SQL is not like, this is called a standalone abstraction, these three. This is the standalone abstraction. RDD, data frame, and data set. But this Spark SQL, this is considering Spark SQL as a unifying declarative abstraction for structure enhancing and usability and accessibility of Spark data processing. It is part of evolution of real and new data abstraction in Spark. So this is the very important part which you need to consider when we talk about the, you know, if you watch many videos, YouTube video, or any classes on the web and many website, many materials, many book even, it's confusing. But I clearly, you know, I have a lot of experience for the Spark, so I make very simple, you know, a slide related what really data abstraction in Spark means. So I'm going to explain one by one, and I will make some comparison table. For making comparison table, I spent too much time to you know, compare those five you know, abstraction. So remember, many time we will refer to these five until data abstraction in the Spark section finish. And in the hands-on practice also we will touch with the DAG or RDD or data frame. So you need to remember, this is backbone of the you know, Spark hands-on and practical concept. And even when you you know, when you participate in some interview, they will ask you this sort of question. You should understand deeply of the Spark data abstraction, and that is very important. And I highly recommend it. Many times watch my video. I really you know, for every words I created by myself, and many times I changed to make it simple for a student. So let's dive into these five you know, data abstraction. So we already explained why we need data abstraction, what is purpose of data abstraction. Now come for practical. So because RDD was the first data abstraction introduced, it is low level abstraction, and that is good for fault you know, tolerant and distributed computation. The another one is a data frame, little bit high level abstraction. So this is optimized for SQL like operation. Later on, Spark SQL also come to the market. And data set has advantages of RDD and data frame combined, and these two, because each one has a, this is the high level, and this is a low level, this is the high level. So in that case, each one has a pros and cons, right? So to keep both advantages, so combine together. And this is considered unified abstraction offering types, which is good for optimized execution plan. So another, this is the data abstraction, but there is a graphical data abstraction which is directed a cyclic graph. A here makes negative. This is like cyclic, means the graph, for example, here you start from here, you make every operation. This has meaning, node and link has a meaning in the DAG. So in the DAG, if something again like this and come back again here is some sort of circulating, this is not DAG. So DAG means you have only one direction, another, and then go another, never come back. So this is the DAG graph type, which is backbone for a Spark computation process. So already explained about the Spark SQL. So let's dive into one by one. So remember RDD, data frame, data set, DAG, and Spark SQL. So before we go inside here, we will start from RDD. Let's put some information about the evolution and then go inside. If you see the evolution start, RDD is not quite long time, is around the 10 years, 15 years, something, right? So start RDD, then 2013 data frame, 2015 data set, which is combined of both, Spark SQL 2015, Spark 2, because until here it is Spark 1.3. So here started from Spark 2 2013 and now is Spark 3. So when we look at this one, as I mentioned, this is the low level, and immutable, it means it is not easily can be changed. Functional programming, we already talked the others. So this is for fault tolerance computation controlling. This is the high level, and is a schema supported. This is make data processing simplified compared to the RDD, and then for data set is combining of both of them. And Spark SQL is a declarative abstraction for a structured data query, and introduced by Spark 1.3. This is good to doing any using the SQL syntax. So this Spark SQL integrated with the Spark dataset abstract and Spark data frames. This is the new one, and Spark 2. That is including all of others with more clear pipeline, and Spark 3 improve performance of the SQL, Spark SQL, and has a optimization, let me color change, for advanced optimization for query. So this is the history, or let's say evolution of the data abstraction in Spark. That is very useful for preparation. This slide I spent a lot of time to make everything very clear in a very great order. So let's go inside RDD. When you look at RDD here, so RDD is the immutable, this is the abstraction, right? The data abstraction. So there is a concept for a distributed data set. There is a resilient that means immutable, protect, and resilient means try to protect to not easily to change data. So this is the point. So in the practical part, you will see in hands-on practice functional operation. I will explain what is the map filter, showing the advantages of the RDD. So this is the point you need to. So another very important characteristic of the RDD, which is lazy evaluation. Why we call RDD in the Spark calls lazy? Because there is a procedure which transformation on the RDD are not executed immediately. It's a lazy, it's not quick. Instead, these transformation are deferred, means delay until one action is invoked. So in the RDD, we will see in hands-on practice, you define something like map or filter, reduce, some function, you define. And this is a transformation step. And then when you define in the logical plan, in the physical plan, you want to do action. So it takes from the defining part to action part when you want to do distributed processing. So this is very great point. It takes some time. So that's why lazy evaluation. This mechanism has a reason to put lazy evaluation. It is very crucial role in the optimizing execution in Spark. So there is a many reason for this sort of lazy evaluation. One is the transformation deferral. When we define like this map, filter, this is function, we define a logical execution plan rather than executing operational immediately. When you define this, nothing happen until action. These transformation generate a linkage, means like a DAG of operation that all Spark use later to determine best execution strategy. So that's why lazy evaluation is important. Another is the optimization of execution, reduce redundancy, fault tolerance, flexibility. So these all come from this lazy. This is very important. If I consider lazy evaluation, very important characteristic of RDD. So RDD has some limitation. That's why the new data abstraction came to the market. This is not schema-based supporting. This is really you need to manual optimization for RDD. So that's why new data abstraction, no need that optimization manually. High memory overload, this is another. So we already can see here, this is very important characteristic. Lazy evaluation, already talk about the in-memory computation. So persistence, so that's why we call it resilience. So it can divide partitioning. So in the hands-on practice, we will do partitioning. So this is based on the location of cluster. We divided, put several city places. This is good that you divided to several small pieces, operate together, and automated false tolerance. This seventh benefit of the RDD. For this slide, one slide, I put everything. Many times I change to make clear, simple, understandable slide. So another and second Spark abstraction, that is data frames. So data frames is the second data abstraction. So that is distributed collection of data organized into names, column, and conceptually similar, relational table. data frames. You're already familiar with this concept, right? When we try to talk about many concepts when we were talking about data visualization, those part, data frame is similar table organized through the column. So use Catalyst optimizer for SQL-like query. So this is good. This is schema-based, especially good for semi-structured and structured data. Easy integration with the other data format, and already good for declarative operation. So data frame has some problems, so that's why in the data set solve this problem. As you see, RDD has some advantages, some disadvantages for RDD. For example, not schema based, but here is a schema based. But that one is for unstructured data. This is for structured and semi-structured data. So in this case, limitation, we have already not compile time, safety, error catch at runtime. Less suitable for functional programming use case. So this is good for ETL operation, for data processing step. Okay, let's see for the next one. Data sets. So data sets is a combination of the RDD plus data frame. So data set including both. RDD is a functional programming, data frame is the relational, and it is sort based and schema based. So to receive the advantages of for example, this is type safe. Data set gets something from here encoded based on data frame and data set. So this is the point of combination of the feature of the data structure and data frames. So a key feature, compile times, safety using the encoder for Java and Scala. Combined best feature for RDD already talk. We already talked about the Catalyst optimizer, because Catalyst optimizer already defined in the data frame will be transferred for data set. There is still some limitation for data sets that is not available for Python and R. So this is the limitation for now. A little bit is slower than data frame, because combining RDD together a little bit slower. So this is the structural data processing with a strict type requirement. So for this sort of data set, data abstraction. So we already finished 3 fundamental data abstraction of the Python for Spark. So now little bit talk about 2 more abstraction, which is not considered as a preliminary abstraction, but it is very useful and considered as a very popular data abstraction in Spark. So let's go. Okay, Spark SQL. This is declarative API data structure through the SQL. So basically start from the user, as you can see here, start from the user, and then go through the query processing and see if you have a DB, NoSQL, or RDB, HDFS. You can manage all other query, SQL query based through the Spark connection. So that is good. This is providing runtime syntax analyzing, error checking. Use the Catalyst operation pipeline, which use like for data frame and data set. Support fundamental data abstraction like RDD, data frame, and others. And Spark SQL give the opportunity for seamless integration. This is very important. seamless integration for external data sources. So more advantages of the Spark SQL, unified relational and functional APIs, and also simplifies data processing, enhances performance, and supports seamless integration of ETL and analytics tasks. Especially this is good for AI analytics. So now let's go dive into last data abstraction of the Spark, which is DAG. So DAG, as I mentioned before, what you can see here in this slide as well, this is any graph which is loop based, so you can see the direction, start from here, go here, and then back again. So this is the directed, right? But when we say some sort of directed which is acyclic, means only direction start and never back to the same node. So this is the characteristic of DAG. So this is good for represent a logical execution plan, specifically when we define, from the client, you want to do, for instance, in your office, you want to do some sort of analyzing based on traffic information, but some traffic data from Seoul, from Busan, from Daegu, 3 different cities in South Korea. So you want to do analyze, send a job to them, 3 cluster, so several jobs or tasks, parallelize, using the parallel processing. So in that case, you can draw a graph as an abstraction to see what's going on. And that is convert from transformation into a stage. So when we defined logically, that is transformation, we define the all function. But when we do action sent to the cluster, that is a stage, and usually is the action through the a stage here. Every stage has maybe many tasks, many job inside. One stage, many in each cluster. Maybe one cluster, several stage. So for example, in Busan city, there is a 3 stage, and each stage several tasks or job. All is a one cluster. So this graph can show this is good for optimizing by minimizing the shuffles and maximizing the parallelize. So this is the power, great power of the this sort of data representation. So now let's put all of this together with one table. Which one? Those 5 data representation. So I'm going to put these 5 Spark data representation in a table and compare together. As you can see here, this is very nice table. I will make bigger size in the next slide. So you see these 2. If I put this one here, so this is until 5 rows, this is 1. So these two table is same as this one. So for example, type safety, and then performance, ease of use, API support, interoperability. This is this slide. And the second one, compile time, safety, memory overhead, use case, complexity, and execution model. So as you can see, we have our RDD, data frame, data set, and DAG, and Spark SQL. I spent too much time to prepare this table for you to make a very clear, understanding of you know, uh, data, Spark data abstraction, which is very important for understanding the Spark. So let's go for the next slide. Start from here, is bigger and clear. So as you can see, type safety, DAG, and doesn't applicable for this one, because DAGs consider for execution model, not logical and conceptual part. So type safety, it is related to the data type. For instance, if one variable is integer and one variable is a string, and you do some operation, integration, for example, A, this is the B, so you want to multiply A and B together. So if the type safety, there is no type safety, that means compile this one, when come here, error. But when fully type safety, that means before you come here to this stage, will be manage error and produce, for time management. In a type safe system, such an error are caught early during coding or compiling, whereas in non-type safe system, these errors are only caught when the program is running. So this is, a big issue. This makes type safety a useful feature for avoiding bugs in your code. So this is the very important point for differentiate between several data abstraction in Spark. Performance. So this is the manual optimization. This is the use the catalyst optimizer. Do optimization query based and improving the performance. So for the data set, same, and for DAG, using the shuffling and maximizing, parallel processing. For Spark SQL, manage this one efficiently, because including both. Ease of use. This is the higher level. So the advantages of this one, and functional programming. This is the functional programming, low level. So ease of use. This one advantages high level. This is low level. The data set has both of them. So for DAG, automatically handle, task scheduling. So SQL-like syntax makes it is easy to use for structured data queries. So this is basically change the structure based on the SQL. So API support, functional API. This is SQL-like API. This is both advantages of functional and SQL for data set. Not exposed directly to the user, part of Spark internal optimization process, DAG, using the graph face. So this is unify API for structural data, integrate with the RDD, data frame, and dataset. So these three advantages for API support come to the Spark SQL. So interoperability means operation between several sections. This is limited, but this is highly interoperable. So this is good for clustering. So same as data frame, but something more, integrate for the type safe for error handling, something more. You can see when we come from here to here, we will see some progress. So DAG interoperability support all of formats, and this is integrates seamlessly with external data source. So this is the advantages of the Spark SQL. So let's continue our table. For compile type safety, I already explained. So compiling that time, no compiles time safety, but this is partial. This is very strong, not applicable. No compile time safety error appears at runtime. So this is the generally make a new model. Memory overhead. RDD has a, because Spark is based on the memory base, so memory management is good. So higher RDD at the beginning was a good, but higher memory usage. But in the data frame, lower overhead, but in the data set is a similar data frame. So DAG, memory usage depend on the task. So Spark SQL is a medium, memory management. So use case RDD usually is good for low level when we would like to define the transformers as a conceptual model and then action on the cluster. But for use case, usually if you deal with a low frame, this is good. And this is if your application is the structure data analyzing. So in that case, data frame and Spark SQL is good. And this is suitable for application needing structure processing. And this DAG essential for all Spark operation manage execution. So use case of DAG when we want to analyze any any operation which is node, and then connection between two operation and to know the direction. So this is the use case. In terms of complexity, since this is the beginning, it was more complex, but in the SQL is simple one. In the DAG is based on the abstract based. So this is this is simple one, and this is also simple and flexible. Because consider both of them. So execution model operate on the partition without query optimization. Partition means when you have a data, I explained before, I will explain later on in the hands-on practice more. So when you distributed your data, you partition means divided. So that means you will do executing but no optimization. So this is the RDD. But in the data frame, little bit more optimization, in the data set more and more, and in the Spark SQL, the best one. And DAG also provide the backbone for task scheduling, fault tolerance. DAG is a general tools graph face for most of the case. So this is the point what we need to consider. Okay, and now let's see another table for feature-based comparison in addition to this table. So as you can see here, we will see RDD, data frame, data set, DAG, and Spark SQL. So immutable means it is not easily changed, so is a resilience. RDD was a good, all is good, so this doesn't care for this because this tree is a preliminary Spark data structure. Fault tolerance, yes, everything. Type safe, this is no, so it started from here. This doesn't need because totally is based on the SQL type. So schema support no, from here support the schema, yes, but this is not applicable, yes. So execution optimization manual, this is catalyst optimizer, this is same. So for the DAG, you should consider that the task parallelism come from parallel processing for task and for data. So optimizer engine, so the RRD is lacking, but others is okay. This is DAG is internal, and API level for data manipulation low, but here is a high. Language support, the problem of data set, see here no Python. So using the SQL-like queries, simply integrate with the RDD and data frame. So compile times safety, this is no, but this is partially, this is good. So you see, and this is doesn't need. So this is data set and SQL Spark SQL, that would be great performance overhead. This is high problem. So here is a medium, but this is a graphics managed very well. So best use case for low level any transformation. This is for structure queries. This is for a structure query with a type safety. This is execution for all Spark computation. This is very useful. DAG can be used. Analytics, ETL, remember, for pre-processing before we do some like data ingestion, remember, right? This is the feature-based comparison. So until now, we easily, through some table and some slide, compare these data abstractions. Now is the time to quickly see some steps how happen. So if I explain this, Spark finish. I will not go for detail one, because detail will be covered in the practical part. From now on, I call it a Spark workflow. So that means how one data will be partitioned, divided, and then sent to the cluster. What is the technical terms for that one? So few slides I will talk, but to understand more, I will do some hands-on exercise and practice some code in the lab lecture part. You will understand more. Unless I don't go for a practical part, maybe it is difficult for you to follow, but I try my best to explain here theoretically. Later on in the lab lecture, we will do some practical part. Okay, very nice slide. I enjoyed to create this one for you. There is a remember, for all ecosystem of the, or let's say a workflow, from the time we want to use, for example, our data. I want to do some application, AI-based application is not based on one database, several nodes. Here is a just put two. So you have you want to do a process like here. So all of them call it cluster. So you need cluster management. Driver manage with the request of the user and manage, integrate execution of a task across the cluster. Because you want to do here zooming, in this computer you want to searching, in this computer you want to do, for example, visualizing. So it's when you integrate, driver is as a orchestra leader. So try to execute the task, means analyze your, here is a task. Can you see? Task manage in each cluster. Executor is here. Perform our actual computation on data, because data is distributed, analyze is distributed, and store data and intermediate result in a memory and or disk for processing. So three important part for a Spark workflow. We will see in the code, we will see how practically we can do a driver part, cluster management, or executors. So this can be easily, I will show in the Spark application. So usually driver communicate with the cluster manager, you can see, to allocate resources. This resource means executor. So cluster manager assigned resources means executors, means perform actual computation on data. So resources means you divide your computation capability on data. across each node. So cluster management will be decide where is our data and which analyze we have in each cluster. So executor execute task on distributed RDD partitions, deliver result back to the driver. So executor, RDD is here. We will partition first and then send to here. So execute task on distributed RDD partition, deliver result back to the driver. So three important. So here is a mostly logical part. Here is a physical part. We will talk more. Here you define method. There is no action. So that's why remember lazy evaluation. That lazy evaluation because everything is here is a lazy. And everything here, no any action. You define filter, map, everything. Action start in the cluster by executor. So this is very important you understand. I can show you some other figure in the next slide. So here you will see again driver cluster management. So in the driver see you are here, here driver partition here. This is for RDD example. You partition and then send to the schedule DAG schedule. This is the on the cluster. This is one cluster. So action done. So here is the executor. You send here. So role of the driver is integrator of many Spark application, manage RDD definitions, transforms, and actions. So if you are using the RDD, if you are using dataset, data frame, or Spark SQL, is same thing for orchestrating those. This is example for RDD. So driver build a DAG here, make a DAG graph of the RDD operation and assign task to executor. So here inside the driver you draw the graph, which we call it DAG. So how many data I have and how many operation. Then send to cluster. Which data? This is only one cluster, maybe another cluster here. Or even I'm talking about one user, but maybe several user. Several user, many cluster. See? So in the practical part we will see that is area for each user, which is a Spark session. In the code I will show you a Spark session, but all Spark session it is in a Spark context. And go to the executor. This is same as this one. Here we have a executor, cluster management, and application. Here cluster management directly contact to the each cluster. Each cluster inside has a executor, cache managing the executor task, and then here is a driver program which through the smart context, in the driver can manage the procedure. Okay, so let's see the executing job. So when we do jobs submission by driver program initiate job and send task to executor through the cluster. So transformation and action created, here transformation and action. When we have a RDD, we have some transformation means we keep it until action done. So we define many function here, which is backup. When you do is action. This strategy is the RDD operation. So you can see a Spark object consists of every object, every task. For example, you want to do some sales managing. You have some transforms means map, filter, and action means collect, do something. So every job, RDD job, is including these two parts. And DAG, which driver create DAG. So who create the driver? Which organize tasks based on their dependencies. So this is the two important operation of the RDD is a transformation and action. So this is create the new RDD and operation trigger actual computation. And how RDD enable fault tolerance, RDD maintenance linkage, allowing Spark to reconstructed lost data. So how executed a job, so scheduling, executing by cluster management, task performance, and then collecting result, that's all. So easily we could say I'm finished, or I finish only this slide and 2 more table. That's all. We will finish Spark, don't worry. And to understand the real meaning, I will show you in the code, not here. Here is the theoretical part. So driver, executor, cluster management, and Spark context. Before it was a Spark context. Later on in the new Spark section will be added. So as I told you, defined what we need. It is the logical plan, and we do action, especially on the cluster. We call it physical plan. Okay, let's go for the table. So here we will have several steps. Step 1, initiate a Spark context and session, create a RDD. So still is the no any even logical. When we load data to the RDD, we use the data abstraction. We put the data. This is the logical plan begins, and then partitioning in the RDD. That is the when divided data. So this is the track in the logical plan. So until here logical plan, no physical. Physical means real. Here is the theoretical part. Here action. So until here we apply methods, create a DAG until step 6. So then we need to optimize our graph. Here we make a graph. Is a logical plan optimizer. So we prepare physical plan, but from here real action start, data shuffling, and the logical plan optimize for logical part. And action means we collect or show data in the cluster. This is physical plan. Save our data when the result come, and then optimize workflow, debug. So this is a start from data to the cluster, several cluster. One user wants to communicate. How happen? Through this 12 step. This 12 step in hands-on practice I will show by code. That was it is here good, but that would be very interesting there. And then let's go here. So here you see just I put driver, executor and cluster management, and metadata flow and data movement, how data move. So this is another direction. So initial, when you initialize, allocate the executor not do anything. Data, data movement we don't have. So until here, no any data move, because this is the physical, logical planning, means conceptual, theoretical part. And then physical is here. You need to do some action. So very interesting, right? Very nice table I created. Very complicated issue, I make it very simple within one slide. This is nearly 100 slides in many classes in the internet they teach, but I make it very simple for non-CS student, as well as good for computer science student. So load data, when you do load data, nothing cluster happen, nothing executing happen. Even when you define the graph is a theoretical part. But here, when you start generate physical in step 8, then start task executing means some shuffling is required, is just started. Driver to cluster manager and executor. This is the metadata flow. And trigger execution, do something, collect for me, show something, calculate this one. This is means some trigger execution. So we will have a data start processing. So here, coordinate saving result, ensure executions until this is the other thing means just checking and monitoring the result. That's all, and do action and return back to the to the sender. So we already finished Spark part, and then we will for big data actually main part finish. Other part is very simple. Within short time I will explain in the next lecture. But big data, real understanding, deep understanding, and implementation of real big data, that was this one. Other things, a small thing I will explain later. So let's recap what we already discussed for this class. For the lecture 7 part 2, we start from so let's quickly go for we started from MapReduce. It was for part 1 of lecture 7. In the part 2 we started introducing more detail about the Spark, showing that Spark is very good for processing and analyzing, not good for storage. Talk about pros and cons. We can return back some core. We explain, we compare Spark and Hadoop together and seeing this is based on only HDFS. This is any data can use concept of partition is a Spark concept, which is, you remember, a driver is doing this one, as well as many cluster that is good. This is the Spark Hadoop comparison. We compared, and then we started very interesting section, data abstraction, and introduced 5 abstraction. This is 3 fundamental, and this is supportive, DAG and Spark SQL. So one by one, explain what is the RDD, lazy, especially lazy evaluation, what is the characteristic of the RDD, and data frame, data set, and we said data set is integrating of the RDD and data frame, and SQL is a new version of the SQL. Then talk about the DAG, which is the graphical acyclic, means not cyclic graph. So then the comparison table, explain each characteristic of these 5, and one more table, feature based, we made comparison those 5 data representative. I think workflow we already talked, and then we talk about the Spark workflow, main component, driver, executor, cluster manager, Spark context and session. We whole workflow, these 4 is under logical plan and physical plan. In the logical plan we define what we need to be done simply, very nice word. How? Very complicated issue I explain in a very simple way. In the physical, define how to do. And then we talk about the 12 step for this procedure. Start from driver to cover logical plan and physical plan. We have a 12 step. So 12 step from 2 different aspects I already explained. Yeah, great. So thank you very much. Hope this last section of the recapping lecture 7 part 2 helpful for you to recap whole today lecture. So don't worry, main part of big data finish, a small part not very difficult remain, and then big data finish, and then we will go for hands-on exercise.